All right, so for practice 2, number 3, for the parallel circuits, we are going to look at the problem that reads two light bulbs, one with twice the resistance of the other, are connected in a 9-volt battery. So this means that the battery is going to have 9 volts, 0 coming in and then 9 coming out in the parallel. The total current in the circuit is 3A. So we're going to fill in all the things that we know. We know that 9 volts is the total, and the total current is 3A. And then that means we can fill out all our circles. So we have a voltage at this point is going to be 9, 9, and 9. Now the current has the option to go through this first branch or the second branch, and it will only drop until it reaches a resistor. And so this voltage drop is 9 volts. This voltage drop is 9 volts. So after it goes through the resistor, then the voltage drops to 0, and we have 0 all the way up until the negative terminal of the battery. Now to get our total current, we know, our total resistance, we know that we have a total voltage is equal to our total current times total resistance, and we have 9 volts is equal to 3 amps times the total resistance, and we divide it by 3 amps. We have 3 ohms is equal to the total resistance. And so next what we can find out is how much the resistors values will be. So we know it's given to us in the problem that the total battery's voltage is 9 volts. Then that means the voltage drop for 1 and the voltage drop for 2 are also both 9 volts. Now we can find out what the total currents are and the total resistances. So first, let's find out what the total resistances are. So there are two ways that we can do our resistances. So we can do the resistance total is going to be 1 over the total resistance, which is equal to 1 over R1 plus 1 over R2. Now, I know we're not big fans of fractions, so another way we can solve it is the total current is equal to the current of branch 1 plus the current of branch 2. So how we can do that is we have we know that the current of 1 is going to be twice as much as the other. So we can decide that the total current for 1 is going to be twice as much as 2. So that means the current for 2 is going to be less. All right, so what we can do now is we have the total current is equal to 1 plus 2 times, we just set it up. So we have I1 plus I2. So we are going to take what I1 is equal to and replace it with I1. So total current is equal to 2I2 plus I2. So we have 3A is equal to 3 times branch 2 current, which is going to be 1 amp. So the current for branch 2 is going to be 1 amp. And then that means the current for branch 1 is going to be 2 because it's twice as much as the other. Now let's go ahead and solve for the resistances. The resistance for 1, so we have a voltage drop of 1 is going to be equal to the current of branch 1 times the resistance of branch 1. We have 9 volts is equal to 2A times resistance. So if we divide it by 2, we're going to get 4.5 ohms, which is equal to first resistance. And now for 2, we're going to do the same thing, or we also know that R1 is equal to, or 2 R1s is going to equal to R2. So if we do 2 times 4.5 ohms, we get 9. And a way to check our work would be the voltage drop of 3. The voltage drop of 2 is equal to I2 times R2. So we have 9 volts is equal to 1 amp times R, and that's going to give us the second resistance, or the second resistor is equal to 9 ohms. All right, now let's go ahead and draw our schematic. So we have our battery, and then we have our ammeter, and we have an ammeter here, and we have an ammeter and a resistor. Oh, sorry, a light bulb. It doesn't actually really matter, but we'll stick with this. So a light bulb and an ammeter, and then same thing, we have an ammeter here, a light bulb, and an ammeter, and we'll fill it in. Our total is 3A, then we have 2A in our first branch, and we have, this should say 2A, and this is going to be 1A and 1A. Now, how we're going to letter this is going to be a little bit different. So we have A, we have B, and then we have C, and then once it comes out of the resistor will be D. And then we'll just do E after the ammeter. Because we have another branch, we're going to call it a different name. So we have C prime and D prime. And we're going to do our letters, and we went all the way to E, so A all the way to E. And let's go by 3, so 3, 6, 9. So at point A, we started off at 0, then at point B, we went up to 9, point C was 9, D was 0, E, and A. And then we're going to connect all the dots. Oh, I should have done it in this yellow color. Okay. All right, so now we're going to do the prime. So at C, we have C prime and we have D prime. And so then we'll just draw it closely to our yellow line. And this is how our problem should look at the end.